make sure on tomorrow's test, if you can't do anything else, make sure that you are able to plot points. That would be from just what we talked about. If you're not able to plot points, you're going to be in trouble. Because when we got into the transformations and all that, obviously you're dealing with points. So make sure you can plot points. But locus of points. Here's all your different scenarios for locus of points. If I give you a dot and I say, okay, plot for me all the points that are 5 inches from that dot. Okay, a set distance from a point will always be a circle. What if I gave you a line and I say, okay, draw all the things that are 5 inches from that line? Make sure that it could be actually 5 inches above or 5 inches below. So all the things I set distance from a line would be parallel lines. What if I want all the things that are the same distance from each of these two lines? Well, the points in the middle, okay, would be the same distance from each line. So that would be kind of the same scenario backwards. So all the things that are a set distance from a set of parallel lines would be the lines in the middle, kind of like the median of a road. Let's see, what's the other one that I'm forgetting? I don't think it's on your test, but all the things that are a set distance from a circle, let's say all the points that are 2 inches from this circle would be all the points that are inside 2 inches away or outside 2 inches away. Okay. Oh, here's the other one I remember now. And I'm going to draw this one a little bit different than I did the first time. I want all points, and this makes you think a little bit more. I want all the points that are the same distance from each side of these lines. Okay. Anytime you have an angle, and you want all the points that are the same distance from this side of the angle as it is from this side of the angle, do y'all remember the two words I'm looking for there? The set of points would be called the same distance from here as it is from here. It's somewhere right in there. Thank you. The angle bisector. So in order to find all the points the same distance from each side, you would cut the angle in half. This point is the same distance from here as it is from here. Okay, as long as it lies on that angle bisector. But if you wanted all the set of points here, you see that all these points would be the same distance from here as they are from here. And you have to actually go a step further. The same distance from here as it is from here, that'd be the two sets of angle bisectors. I'm not going to give that one to you, though. The one that I'm going to give you is an angle, possibly. The set of points that are the same distance from one side as it is the other side would be called the angle bisector. Okay? It bisects it. Got all those? Make sure you know how to find slope given any 2 points. The only mistake that I see people make on this, if I give you 2 points, say this is my 2 points. If I give you a set of 2 points and I ask you to find the slope, slope formula is y2 minus y1, the second y minus the first y. Now, here's something we didn't cover the first time we went through it. This is my first point, this is my second point, right? Doesn't matter. Did I have to write the points in that order? That was just how I wrote them down. If you let this be your second point, that is fine. Just let this be your second x, this is your first x, this is your this is your second x, this is your second y, this is your first x, this is your first y. Okay? It does not matter which one you let be your first point, which one you let be your second point. Just keep it the same the entire problem. Okay? So let's find this. Now I'm going to do this as second, this is first, just because it's easier to remember. Your second your second y minus your first y. Here's the other mistake that I see people make. If it requires 2 minuses, put them both. The second y value is -5 minus. This minus right here came from the formula. The formula has a minus in it. This minus came from the actual number. 2 minuses make a plus. -5 plus 3 would be -2. On bottom you have the second x minus the first x. That one does not require 2 minuses because this 2 is positive. -4 minus 2 is -6. Oh, that worked out good. Anytime you have a minus minus, make it a positive, because a negative divided by negative is a positive. Anytime you have a negative and a positive, you can put that negative anywhere you want to. Top, bottom, out front. Your order, divide if you can. You can't divide here. It's a decimal. Divide, reduce, leave it. This will not divide, but it will reduce. 2 and 6 will both divide by 2. That's a positive 1/3. If you're given a graph, make sure to find any 2 points, and instead, now if you would like to, you can pull the points. Like you could actually say, okay, this point is -3, 6, this point is 0, 8, and you could actually use that slope formula again. I wouldn't. If you can count, you can find slope. Rise here, its slope is also rise over run. Rise is 2, run is 3, slope's 2/3. Done. The 4 different types of slope: uphill is positive, downhill is negative. Horizontal line is 0, vertical line is undefined. Something else that I would like for you to be able to do on this test. Be able to recognize linear equations or linear lines in their equations within 5 to 10 seconds. I mean, I want it to be that fast. If I give you this line, you should be able to give me the equation within 10 seconds. We just gave you half the answer. Equations look like this, guys. To get the equation of a line, you need the line's slope, and you need its y-intercept, and you're done. What do we say the slope of this was? So y equals 2/3 x. Right there. Everybody always forgets to put that x in there. Okay, the slope is attached to the x. Y equals 2/3 x plus, where's it cross? 8, right? Done. That's the equation of that line. The other one over here, y equals, my slope here is going to be negative. Find any 2 points. Well, that was easy. 1 and 1. -1 over 1 is just -1. And if you want to put an 1 there, that's fine. I know that it's there. You don't have to put it. So -1x plus 5. See how fast those equations are? The slope and the y-intercept. There's your y-intercept. It crosses at 5. So given 2 points, here's all the different things on the test that I could do to you. Let's just take these 2 points, -5, 3, and let's play around with them. -5, 3, -3, -1. Let's talk about all the, because this right here is going to be a good review of everything on the test. If I give you 2 points, number 1, I could ask you what the slope was. If I ask you for the slope, then do y2 minus y1 over x2 minus x1. Number 2, I could ask you for the equation of the line that passes through those 2 points. And the equation, what I mean by equation, the y equals mx plus b. Let me remind you on how to find that. If I give you 2 points and ask you for an equation, well, first you need a slope. y2 minus y1, anybody help me with that? Negative, good, 4. Over x2 minus x1, -3, can anybody do that in their head? -3 minus -5, good. Minus minus would be a plus. Your slope here is -2. A lot of people circle it and put, hopefully on the test tomorrow you'll see the answer choices and know that -2 is not the answer. Okay, that's the slope, because I asked you for the equation. Now you have 2 options from here. If you're looking for an equation, you have point slope, which into point slope you plug in a point and you plug in a slope, clean it up, you're finished. Or you have this y equals mx plus b option, which I actually prefer. Y equals my slope, I just found it. I need a y-intercept. I need to know what the y-intercept is. Okay, it's not given. -5, 3 is not a y-intercept. -3, -1 is not a y-intercept. Remind me, how do I know that neither one of those are y-intercepts? Thank you. I heard the x, huh? The x is not 0. -5, 3, that's not a y-intercept. -3, -1, your x will be 0 if it's. Now, what if one of the points was 0, -1? Do you have to go through all this work? No, that's your y-intercept. Plug it straight in, you're finished. And sometimes they'll do that to you. One of your 2 points, they might actually give you the y-intercept in those points. Watch for it. But here's what I'm going to have to do. Since I do not have a y-intercept, you could graph it. I wouldn't. I just plug these points in. Let's plug this one in. So when y is 3, x is -5. So -2 times -5 is 10. 3 equals 10. Wrong. It does not. Make it true. 3 equals 10. Take away 7. So this would be y equals -2x minus 7. That's the shortcut way. Like I said, if you want to work it the long way, that's fine. Work it the way you want to work it, the way that you can work it. Let's just check that. Let's just look at this graph. See if it looks like y equals -2x minus 7. Looks pretty good, right? See what's going to cross down here at -7? We're pretty accurate. Slope is -2. Yeah, all good. What else could I ask you to do? Okay, let me erase that. Given 2 points, I could ask you for a slope. I could ask you for an equation, which is what we just worked. Why did I erase that point? Let's try that again. Or I could ask you for the distance between the 2 points. I could ask you for the midpoint between the 2 points. So let's do distance. Remind you on what distance is. There is a distance formula. It's on your formula sheet. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If you know how to do the Pythagorean theorem way, go for it. Pythagorean theorem, your distance here is 2, the distance here is 4. Should be 2 squared plus 4 squared equals c squared. Finish solving it, you're done. But here's the other way. x2 minus x1, -3 minus -5. Hey, seems like we just well ago did that, right? -3 minus -5 is 2. And again, when you subtract, you're simply finding the distance between those things. That's all you're doing here. -1 minus 3 is a -4. That's the square root of 4 plus 16, which is the square root of 20. That's an answer. It's not simplified. Any perfect square roots in 20? I know the square root of 4, 9, 16, 25, 36. That's too big. Any of those located inside 20? Square root of 4, which is 2, right? Does everybody see the 4 in here? Everybody sees it, right? Break the square root of 20 into the square root of 4 times the square root of 5. Listen as I do that. The square root of 4 times the square root of 5. The square root of 4 times the square root of 5. They're simplified. Or you could go this route with it. The square root of 20 is 4 point something. 4.4. So any of those answers, I'm not going to say would be fine. It's multiple choice. So if you have the square root of 20, and it's not, I'll go ahead and tell you the square root of 20 would not be an answer choice here. If you need help breaking that down, again, we're still in that process of learning that. If you need help breaking down root 20, bring it to me. I'll help you work that, or I'll come to your desk. If you can get to there, I'm in good shape right now. Okay, the last thing that I might ask you to do is if I give you 2 points, I could also ask you to find the midpoint. Well, I say there's so many things I could ask you on here. The midpoint, you add x's divided by 2, add y's divided by 2. You can look at your formula sheets. You've got the midpoint formula. x1 plus x2 divided by 2. Dylan, what is x1 plus x2 here? Divided by 2 is -4. Good. McKenna, what's y1 plus y2 here? You add them, yeah. 2, divide that by 2 and you get, that should be your midpoint. And you can always test that out. Let's go back to our graph here. Points were -5, 3. -1, 2, 3, 4, 5, 3. There's -5, 3, and 3, -1. Or -3, -1, excuse me. And we think the midpoint is -4, 1. Does that look pretty close? You see that? Question while I have this graph pulled up. I don't want to give you too much extra, but just making you think a little bit. Could you use slope to find the midpoint? You see where I'm going with that? your slope, to get from one point to the other point, you rise 4 and you run -2. Could you just half those to get to the midpoint? And instead of rising 4, running -2, rise 2 and run -1. So take this point and go up 2 and go left 1. Yeah, you could do that too. It's entirely up to you. So there's the next thing that's going to be on it. Also, be able to graph if I ask you to graph these type of equations, being able to recognize that graph. These are all in slope-intercept form. Here's my slope, here's my y-intercept. Again, graphing is one of those 5-second things. 7/2 x minus 2. Plot -2, rise 7, run 2. 1, 2, 3, 4, 5, 6, 7, run 2. Whoop, that's not it. Let's try it. See, Thaxton, that's the reason I didn't do that. You messed me up. I was going to try it, and it messed me up. Let me do this one instead. There you go. There's your line. 7/2 x minus 2. Y-intercept's -2, slope's 7/2. Let's work another one. -6x plus 3. Plus 3. Rise and run. Go down 6. Go over 1. Connect the dots. How many points to find a line? 2. That's all you need. Okay. Why do we add 3, 4, and 5? Pretty much to make sure our line's straight. If you want to add more points up through there just to where you get a straighter line, that's fine. Okay, the two that we might have forgot about, y equals -5. Notice there's no x there. -5 is not the slope. What's the slope? 0. Y equals a number is a 0 slope. Okay, you go down, here's your y-axis, go down to -5, and you draw a horizontal line. Done. Harley, x equals 5. How do I draw that? What kind of line would it be? X equals, there we go. So you'll go to 5, draw a vertical line. There you go. There's x equals 5. That makes sense. The last one, y equals -1/3 x. The only reason I put that one on there with it, that minus out front, you can put on top or you can put on bottom. It doesn't matter where you put it. You can go down 1, right 3, or you can go up 1, left 3. Plus 3 is your y-intercept. So make sure you know how to graph. Some of them is easier to graph other ways. If you're given this on your test and asked to graph it, the best way, especially multiple choice, think about this. On a multiple choice test, you'll kind of be able to you've got your 4 graphs there, and you're going to be able to tell which one's right by doing this. Find a y-intercept, find an x-intercept. I want to drill this in your mind over and over and over. To find a y-intercept, Andrea Gutierrez, to find a y-intercept, what do I do to x? To find a y-intercept, I'm going to take x and plug in. Plug in 0. To find a y-intercept, plug in 0 for x. There you go. I just did it. Did I say that? X is 0. It's gone. So, and now you will divide. What is y going to be anybody? 10. So my y-intercept is 10. Let me clear that. And then find the x-intercept. To find the x-intercept, plug in 0 for y and divide. Somebody do that for me, please. Negative x will be negative, say again, which would be -2.5. That is right. -5 over 2 or -2.5. So I have a y-intercept of 10, an x-intercept of -2.5. There's the line. Multiple choice, you can tell which line it would be. The other method, if you would like to, this is not slope-intercept form. With the 2 steps, you can get it there. If you like the whole y equals mx plus b stuff, watch how fast this is. Your x term, move it over. You now have 2y equals 8x plus 20. 20 is positive, leave it positive. Divide everything by 2. Divide by 2, divide by 2. You get y equals 4x plus 10. It's in slope-intercept now. That plus 10 is the same. Rise 4, run 1. I don't have room, so let's make them both negative. Negative divided by negative is also positive. Down 4, left 1, down 4, left 1, down 4, left one, is that going to cross right there? Yeah, same line. Okay. So that's how you can get in slope-intercept form, or how you can use intercepts to graph. If you're given one like this, where you're given a slope and a point, we saved you a step. It's pretty much what we did here. If we're actually giving you the slope, if you want to use shortcut, y equals 6x plus minus something. Figure out what the something is. Let's work it the long way. Y minus y1 equals m times x minus x1. Distributive property gives you 6x minus 6. Move the 3 over by adding 3. Mark it out. Gives you y equals 6x. Negative 6 and positive 3 is a minus 3. Shortcut would have gave you the same answer, because you would have done y equals 6x blank. Plug in 1 and 3, that'd be 3 equals 6. To make that true, you'd have to subtract 3. You get the same answer. Parallel, perpendicular. Reminder, if you're dealing with parallel lines, they have the same slope. If you're dealing with perpendicular lines, they have opposite reciprocal slopes. I'm not going to work all the way through these problems, but just to remind you. If I ask you to find a line parallel to this line, all the information you need from that is its slope. So I'm looking for a line that has a slope of negative 1, because this slope is negative 1, that passes through the point negative 3, 6. From there on out, work it the exact same way we just did. Perpendicular is the same thing. By the way, if I ask you, are these two lines perpendicular, true, false, whatever, check their slopes. But if I ask you for an equation of the line perpendicular to this, well, this slope is negative 3. If I'm looking for a line perpendicular to it, since this is negative 3 over 1, I need positive 1 over 3, containing that point, which is not a y-intercept. That's an x-intercept. So that really doesn't help you much. It just makes it easier to plug in because of the 0. That's all you're looking for. Take the slope, take the point, plug it into point slope for your shortcut. Same thing. Okay, circles on the test. All circles look like this. X squared plus y squared equals r squared. That is on your formula sheet, so shouldn't forget that. If you want to shift circles, if you want to translate circles, like this circle, this one has a center at 0, 0. This one has a center at 1, negative 8. We've got to shift it. In order to shift it to 1, from 0 to 1, we're moving it right 1. Here's how you move it right 1 spot. Plug in the opposite of 1, x minus 1 squared, plus. This one has been shifted from 0 to negative 8. It's been shifted down 8. In order to shift it down 8, you tack on a plus 8. The radius is 7, so 7 squared is 49. There's the equation of that circle. Again, remember that with circles, if you want to shift it right 1, down 8, do the opposites inside parentheses, minus 1 and plus 8. On the test, if I give you one to where I give you a center, but I don't give you a radius, but I just give you like a point on the circle. If this is the center and this is some point on your circle, guys, the distance from the center to the point is the radius. So you might have to use the distance formula. I don't know, but I don't think I did this to you on the test. I think I did it the pre-calculus on their test, so don't tell them. What if I give you the endpoints of your diameter? There's another way, another route that we could go there. And I know for a fact that I've seen these on some ACT practice tests. What if this is your diameter, and I give you that this is 1,3 and this is 5,7? Just to make you think a little bit. Those are the endpoints of the diameter. Well, how do you find the center of the circle? Midpoint. The center of the circle would be the midpoint of those endpoints. And the radius, you could do it two different ways. If you wanted to, you could find the distance from here all the way to 5,7 and half it to give you the radius. Or you could take the center, which is at, let's see, 1 and 5 is 6, divided by 2 is 3. 3 and 7 is 10, divided by 2 is 5. You could take the distance from there to there, or the distance from here to here. Either one would be the radius. Okay. I might give you that one as a bonus. That'd be a good bonus. The only other thing that's on your test is your transformations that we talked about today. Being able to take, and I should give you, from what I showed you, you've got your rules on that piece of paper. I should honestly be able to make up some rules. Watch this. Negative x plus 3. What if I just made up a rule? It's the same thing. Just apply that rule. And I said, okay, take the point 3 comma 4. What kind of transformation is this? I have no idea. That's pretty ugly, right? But how would you transform that? Well, you take your y, which is 4, and you'd plug it in right here. 2 times 4 is 8, plus 1 is 9. You would take your x, which is 3, and you'd plug it in right here. Negative 3 plus 3 is 0. So 3, 4 turned into 9, 0. That's interesting. What kind of transformation would that be? I know there's going to be a translation thing going on there. There might also be a dilation since you've got multiplication. But any of those rules I ask you to apply. The hardest ones being your rotations, like if you had xy turns into negative y x, and I ask you to perform that on that same 3, 4, well, how do you do that? Okay, where you have an x, you have 3. So over here in your answer, where you have x, put 3. Your y value is, that's a 4. That looks like another y. Your y value is 4, so right here where you have a y, put minus 4. That's how you perform those transformations, which, by the way, which one is that? xy turns into negative yx. That's the 90-degree rotation, 90 degrees counterclockwise, or 270 clockwise. Okay, so that's the last thing that's going to be on your test. And on those, I'll just ask you, rotate this point so many degrees. Or take this point and translate it by using this rule. Or I might say, take this point and flip it across the x-axis. Okay, that's what those look like. You can actually